Hi there, my name is Wong Chun Xiang and I am come from Universiti Hussein, Malaysia. And my supervisor is Professor Mayat's IR Dr. Sun Jing Fong's, and the category is bachelor degree. And I will present my project, and the title is a Bluetooth and Machine Vision Control Auto-Guided Vehicle. So let's start. First is the introductions. COVID-19 burst into endeavors already 2 years, and everyone need to change their lifestyle to prevent the infected by the COVID-19. And COVID-19 virus also can survive on the surface of the object. It's not only directly infected from the infected persons. And there are many high technology robots used in many sectors to prevent the COVID-19 transmissions. Because COVID-19 transmissions, it can classify into two types. The first is the direct and the second is the indirect. Direct is directly transmit from a person to a person. And if it's indirect is the virus is deposited on the surface of the object and it can survive for 28 days. And there are many high technology robots used in many sectors, for example, the healthcare, the logistics, and the disinfections, the manufacturing industry, and so on. So next is the problem statement. And Malaysian government has opened many economy sector and returning to normal. And so the people need to go back to their working areas, but it have a risk of getting infected when touching on an object surface. And so there are a lot of auto-guided cars, robots, trolley invented to prevent the touching on an object surface. And the invented auto-guided cars are using ultrasonic sensor, GPS modules, color detection mechanism, infra sensor, and so on. And this is the ultrasonics and GPS and the infra sensor. And all these mechanisms have its advantage and disadvantage. And for our project, I'm using the Husky lens as the AI visions. Is a AI machines sensors to sense the label and follow it. And the objective to design a Bluetooth and vision control automatic guided vehicle AGV to reduce the user contact with the vehicle. Next, the second objective is to design an algorithm to control the system of the AGV. Lastly, to construct and test the mechatronic system of the AGV that can carry a maximum 10 kg load. And next is the scope. Firstly, it is programming the microcontroller. The microcontroller for the AGV is Arduino Mega, and is coding by C++ language because it is using Arduino IDE to code it and upload the code. And next, the development of control app is using IMT App Inventor to design and develop the application to be used in this project to control the AGV using the Bluetooth connections. Lastly, it is building a prototype of the AGV. And firstly, it will have a 3D drawing, and the frame of the AGV is using the PVC pipe, and it is using many electronic components and we mentioned in the methodology. And next is the methodology. This is the model graphic of the AGV. The user is using the smartphone to control the AGV by using the Bluetooth connections in the app. And the label is placed on the back of the user, and the AGV will follow the label to go it. And this is the label used in this project. And next is the block diagram of the AGV. First, you can see the smartphone is connect Bluetooth connection with the Bluetooth module. And this is the AI vision sensor to be used in this AGV. It's a Husky lens, and it connects with the microcontroller Arduino Mega. And the power supply for the Arduino Mega is 10400 milliampere hours per banks. And this is the motor driver to drive the motor, the directions, and the speed of the motor. And the motor driver will connect with the 12 volt power supply with a battery to supply for the two motor. Next is the flow chart. First, the Bluetooth module connect with the app using the Bluetooth connections. And when it is connected, we will check all the situations. When forward button pressed, it will send F to the Arduino and the AGV will move forward. And when the backward button is pressed, it will send B and AGV move backward. And left button pressed, it will send L to the Arduino and turn left. R button pressed, send R and AGV turn right. And stop button pressed, it will send S and the AGV stop. And lastly, the auto guided buttons pressed, it will send A and it will go to the auto guided mode. In the auto guided mode, it will check the X coordinates and the height of the frame. When the X coordinate is less than 90, which means the label is at the left side, and at the AGV with the left. And X coordinate is greater than 230, the AGV will turn right. And the frame is smaller than 40, it will move forwards. And the frame is greater than 80, it will move backwards. And when there are no label detectors, the AGV will stop. This is the road diagram of the apps connect with the Bluetooth module. This is the app layout. You can see it. There are many buttons in the apps, and it is connected with the Bluetooth module using the Bluetooth connections. And any instruction it will send to the Arduino Mega to move the AGV. And this is the Husky lens. It have a learning button and a function button. We just set the functions to be used using the function button, and the frame of the Husky lens focus on the label, and we just press the learning buttons to learn it and save it. And the AGV will follow the label. And this is a coordinate system that used to let the AGV to sense the label at the left side or right side, or want to go forward or go backward. And this is the 3D drawing of the AGV. You can see firstly at the top, you have a tray to let the user to place some things. And at the center front, you have a location of Husky lens. It fixed at here, and it have a circuit and cross box to cover the electronic components we use in this AGV, and it have two motors here to control the wheels of this AGV. And the length of this AGV is 60 cm, the width is 50 cm, and the height is 90 cm. And this is the end product of the AGV. You can see the Husky lens is fixed on the center front of the AGV, and it has two motors here to control the wheels and to control the movement of the AGV. And this is the circuit and crossbox, and to store all the electronic components inside. And the length of the end product is 60 cm, wide is 50 cm, and the height is 94 cm. And in the circuit and crossbox, it have the Arduino Mega at here, and this is the motor driver. Motor driver is connected with the DC motor at here, and the 12-volt battery is also connected with this to supply the power for the DC motor. And this is the power bank. It is supplied the power to the Arduino Mega, and this is the Bluetooth module connect with the Arduino, and this is the Husky lens connections. It is connected from here until to the Husky lens. Next is the expected result. It will show in demonstrations video.
The application is connected to the AGV using Bluetooth connections. Next, it will show the application control the AGV. Forward, backward, right, and left, stop. In this part, is learning the label by using the Husky lens. Just press the learning button and it will learn the label. Now you can see the frame is following the label. Now it shows the forward of the auto guided mode. Now it shows the backward of the auto guided mode. Now it shows the turn right of the auto guided mode. Now it shows the turn left of the auto guided mode. Now it shows the missing label and it will stop. In this part, the vehicle is following the label and walking through a small distance.
After the demonstration video, we continue with the log wave versus the speed of the AGV. You can see the log wave is increasing, whilst the speed of the AGV is decreasing. You can also see in the graph of this result, when the wave of the load is increasing, you can see the graph is decreasing. So we can conclude that the heavier the load to be carried, the slower the speed of the AGV. Next is the map of detection of the AGV. This is the husky lens. The detection angle is 55 degrees here, and the maximum detection distance is 80 cm. So the best following distance is within the 80 cm and the angle is 55 degrees. Next is the comparison between two functions. The Bluetooth control functions, the strength of it is can remote control the AGV. The distance can up to 10 meter and is tested in the previous part. The weakness is it requires the user click button to control the AGV. The user need to be always keeping on an eyes on the AGV, and the automatic guided function strength is no need to click the button to control the movement of the AGV. It is always follow the label using the husky lens. Next is the weakness of the auto guided mode. It is limited by the distance and the angle of detections. The maximum distance is 80 cm and the angle is 55 degrees. So when the user is out of the detection area, it will cause the AGV not function. Next is the conclusion. This project has constructed a Bluetooth and machine control automated guided vehicle that was able to reduce the user contact with the vehicle. The algorithm is also achieved to control all the system of the AGV. And Bluetooth control the vehicle has tested in range 5 meter, 7 meter, and 10 meter. And all of these are functioning well. The auto-guided functions of the AGVs can follow the label of the user nicely. The AGV has to carry different weight of load such as 5 kg, 8 kg, and 10 kg. The heavier the loads to be carried, the slower the speed of the AGV. The best following distance of the auto-guided functions is within 80 cm and the angle of sight is 55 degrees. Lastly is the future work. The body frame of the AGV should be enhanced by adding more support, so the AGV can carry a heavier load that's greater than 10 kg load. It can add on more function by using the built-in function of husky lens. For example, the light tracking functions can be used in the manufacturing industry. And next is need to develop a more advanced application to have a more stable application to control the AGV. Next is add some safety precaution to prevent the crashing on something. For example, the ultrasonic sensor can be used in this AGV. When it sends some object in front of it, it will stop the AGV. Lastly, it can assemble two more motors for front wheels, and so the AGV can carry a more than 10 kg load rather than this project. And that's all from me. Thank you.